Okay, so I was looking at number 3, and I wanted to kind of walk you through the process because the process is the exact same for 3, 4, and 5. So just make sure whenever you're doing a hypothesis test that you always start by defining what your population p-value is. So that's going to be what is kind of in that hypothesis, whether it's, your null hypothesis is equal to, and then your alternative hypothesis will state that it's less than, greater than, or not equal to. After you do that, make sure to state what test you're doing. So that helps you a lot with the AP scores. So for all 3 of these, we're doing a 1 proportion z-test. So I'm just going to write up here in this column. But first thing I said is just say, what is P? And then second thing you want to say is, I'm going to conduct a 1 proportion z-test. Oh my God. Okay, and then after that, you want to state your conditions. So for our conditions, we are doing our first is our normal, or our large count. And then you're going to state your random and your 10%. So make sure that those are all satisfied and kind of just work on that detail because it's going to be what you're going to structure your FRQs like. So after that, I'm going to state what my null hypothesis and alternative hypothesis are. So HO is my null, HA is my null, or alternative. So for this first one, it says that 450 out of 1,000 indicated that they would be willing to give up some personal time to make more money. So that is like your sample proportion. And we're never going to set our alternative hypotheses to our sample proportion. What's going on? Come back here. So this is our p hat, which I'm just going to leave as 450 over 1,000. And in your calculator, iPad's freaking out. Okay. Oh my gosh. Okay, in your calculator, the 450 is going to represent your x, and the 1,000 is going to represent your n. So it says, does the sample data provide convincing evidence that less than half of the women, so less than half, age 22 to 35, who worked full-time, would be willing to give up some personal time? So that is going to tell me what my P naught is. So that's going to tell me what my null and alternative hypothesis are going to be set equal to. So if it's less than half, then my null will always say that my P is equal to 0.5. It's not going to say equal to 0.5, but it's equal to, and then in this case less than half, so 0.5. And then this will say that my p-value is less than 0.5, so that's that 50% that's going on right there. So my p naught is 0.5. This right here is your critical value that you're comparing your p-value to. Now p-value in the sense of your proportion that the hypothesis test is giving you for your calculator. So you're comparing your values to that alpha level to make your decision of whether or not it's statistically significant. So if you're looking at your calculator, you're going to go to stat, and then you're going to go to tests, and then tests, and then we're looking for 1 proportion z-test, which is number 5. So 1 prop z-test. Okay, again, our p naught is 0.5. Our x value is 450. Our n value is 1,000. And since you're doing a less than, then that's going to be kind of the one that you highlight on your calculator. And then you're going to just press calculate. When you press calculate, it tells me that my p-value is 7.8. 7.8 e to the negative fourth. So that's really, really, really small. So that p-value is less than the alpha value. So that's what makes it statistically significant. And when it's statistically significant, we reject the null hypothesis, and we have evidence of our alternative hypothesis. Evidence of the alternative hypothesis. So you're doing the same thing for each number, for 3, 4, and 5. You're going to make sure you tell me what your p-value is, what the proportion, what test you're doing, your conditions, what your hypotheses are, and then just calculating what that p-value is so that you can make that conclusion. So the hardest part, I think, is just being able to define what the p naught is. So like just looking at number 4, it tells us 22% indicated they received commercial messages and ads on their phone. So that's my p hat. That's your sample proportion. Is there sufficient evidence that they received commercial evidence is different than 0.18? So my null hypothesis, again, will be that P is equal to 0.18. My alternative hypothesis will state that P is not equal to 0.18 because it says, is it different than? Okay, so try that one. Let me know if you have questions on that one. For this next one here, is there sufficient evidence to conclude that the majority of U.S. adults felt this way? So majority is more than 50%. So you'll have your P is equal to 0.5, and your alternative hypothesis is that P is greater than 0.5.